Welcome to Study Loop.
Okay, remember that the more ionic something is, and the greater the charge difference between the uh, anion and cation, the stronger it's held together, right? And the stronger something is held together, um, the higher its melting point is, right? That is to say, we can compare, for example, calcium oxide, calcium 2 plus, O2 minus, right? We can compare these to, I don't know, let's just say sodium bromide, right? Okay, which of these is more electronegative, oxygen or bromine? It's oxygen. Oxygen holds its electrons much more closely than bromine, right? Now, which of these is more uh, electropositive? Which of these wants electrons even more, or more easily gives up electrons, we should say, right? It's the calcium. It forms the 2 plus ion, right? Uh, the idea is that these, a positive 2 and a negative 2 cation and anion, are going to hold each other much more closely, right? The calcium is much more positive, the oxygen is much more negative. They will hold each other closely. So you can look at the charge, and then the other thing you can look at is electronegativity. But right off the bat, we can rule out calcium oxide and we can rule out magnesium oxide, because magnesium oxide is also a 2 plus and a 2 minus cation and anion, right? They're going to hold on to each other very strongly because of their large charges. Okay, so that really leaves us with deciding between sodium bromide and lithium fluoride. Well, the problem here is that these are both um, uh, singly positively charged cations and singly negatively charged anions. But what we'll notice is that the difference in electronegativity between lithium and fluorine is greater than the difference in electronegativity between sodium and bromine. Remember, fluorine is probably the most electronegative atom on the periodic table. Okay. It is. It's got an electronegativity of 4. Bromine is fairly electronegative. It's like 2.7, but it's not really, uh, you know, drastic. It's not that close. Whereas sodium and lithium are actually really close. It's like 1.7 and 1.5, something like that. They're somewhat interchangeable. So really, we're just saying, okay, fluorine blows bromine out of the water. Lithium and sodium are pretty close, but lithium and fluorine are um, far more attracted to each other than sodium and bromide, right? Uh, Meaning it's not going to be lithium fluoride, right? Just like magnesium oxide, calcium oxide, they're really attracted to each other. Sodium bromide is like the odd one out, right? Uh, they are attracted to each other, sodium and bromine, but not nearly as much as lithium fluoride or the uh, cation and anion pairs that have double charges.